Welcome to Chapter 8. In this first lesson, we're going to be looking at graphs of derivatives and then using it to make some conclusions about the original f of x function. So let's take a look at this equation here, or this graph. Let's first talk about where f of x is going to be increasing, decreasing, and where it might have some extrema, which is minimums and maximums. So to do that, if you remember back in Chapter 4, when you learned about those concepts, you were given equations for f of x, and then you learned about critical points, which is where the derivative equals 0, and then you solve, you find your critical points, and then you set up a sign chart. You look at the sign of the derivative to determine if a graph is increasing or decreasing based on the sign of the derivative. So nothing has changed. We're still doing that here, except we have the derivative. We're staring right at it. So if we want to find critical values or critical points on this graph, you would look at anywhere where the derivative is equal to 0. So in that case, it's going to be at -8, -1, and 3, because that is where the value of the derivative is equal to 0. Okay, so now let's look at where it might be increasing and decreasing. So again, back in Chapter 4, you would find the derivative, set it equal to 0. Those are your critical values. You set up your sign chart, and now you plug numbers into the derivative, and you determine the sign of the derivative. Again, you're staring right at the derivative. So the sign of a derivative would be the y value. It tells you the points. So in this case, our function f of x is going to be decreasing anywhere where the derivative is negative. Well, that would be down here, and that would be down here. Anywhere where it's below the x-axis would be where the derivative is negative. So that happens at -infinity to -8, and then again from -1 to 3. The graph is increasing anywhere where the first derivative is positive. Well, if you look at a graph is positive when it's above the x-axis. So that happens here, and that happens here. So this happens between -8 and -1, and from 3 to infinity. So again, let's talk extrema and talk about where you have a minimum and a maximum. This occurs where there's a critical point, which means the derivative is equal to 0. Where the derivative is equal to 0, it means the original function has a horizontal tangent line. So these three spots represent a horizontal tangent line on f of x. So then what happens there determines what happens before and after that point determines on whether there's an actual minimum or maximum there. So the sign of the derivative has to change. Positive to negative means the tangent line is going up and then it's going down, or negative to positive means going down and then going up. So we have a maximum in this situation or a minimum in this situation. So this would be like in Chapter 4 when you would find the critical points, you would make a sign chart, you would look at the values of the derivative, whether they are positive or negative, which we just did that by looking at the graph. So that would be the same as doing this right here. And now you would look to see if the sign changes. Well, there's a minimum there, there's a maximum there, there's a minimum here. Sign changes from positive to negative or negative to positive. You can just look at the graph. Notice that it goes from negative to positive. If you read it from left to right, this is where it equals 0, so there's an extrema right there. If you go from left to right, just like you read English, math and English are the same. You go from left to right. This one goes from positive to negative. So now that one's going to be a maximum. And then this is a negative to a positive change again. That'll be a minimum. So nothing changes. Everything is the same. The graph changes. The derivative, the sign of the derivative changes from negative to positive at -8 and +3. So those are minimums. And then the derivative changes from positive to negative at -1. Those are maximums. So you can do this with an equation, with the derivative equation and a sign chart like you did in Chapter 4, or you can do this with the graph of the derivative. It's actually easier with the derivative graph just because you don't have to plug numbers in. You can see the sign right there. It's in front of you. Okay, let's take a look at this graph again in a different way now, because we're going to talk about concavity and points of inflection. And when we do that, we're actually talking about the second derivative. So if we want information about the second derivative, this means we actually have to take the derivative of the first derivative. Again, if this was chapter 4, you would have equations. So you'd have f of x, you would do the derivative, and now you have f prime. And if you want the second derivative, you do the derivative again to f prime, and then you have f double prime, or second derivative. So you actually have to take the derivative of the first derivative to get information about the second derivative. Okay, so just remember back when you learned about derivatives, the basic definition of a derivative is the slope of a tangent line. So if I want to know about the second derivative, then I need to take the derivative of this equation, which I have in graph form right now, not the actual equation, but the graph. So if I want the derivative of this graph, I have to think slopes of tangent lines, and that will tell me information about the second derivative. So for the second derivative, it tells us about concavity. Anywhere where the second derivative is positive would be where the original graph f of x is going to be concave up, and anywhere where the second derivative is negative is where the original graph would be concave down. So here's the deal. We're taking the derivative of this graph means that we're thinking about the tangent lines of this graph. Tangent lines are positive over here. Tangent line is actually 0 right there. Tangent lines are negative here, 0 here, positive here. So we're talking about the tangent lines of this graph because we're taking the derivative of this graph. So anywhere where the tangent lines are positive gives us where f of x is going to be concave up because that's where the second derivative is going to be positive. So that happens here and that happens here. And these are approximates. I know it's not exact here, so I just made this negative 5.5 right there, and then about 1.25 here. So from negative infinity to negative 5.5, tangent lines are positive, second derivative is positive. And this is because we're talking about the first derivative, and if I'm talking about the tangent lines of the first derivative, it means I'm taking the derivative of that, which gives me information about the second derivative. Okay, concave down would be anywhere where the tangent lines on the derivative graph are negative, because that would be where the second derivative would be negative, and this occurs down here and here. And now points of inflection would occur anywhere where the second derivative is 0 or undefined. In this case, we don't have any situations that they're undefined. So a point of inflection technically occurs where the second derivative is equal to 0 and there's a sign change in the second derivative. So again, when a derivative is equal to 0, it means there's a horizontal tangent. So that occurred here and here. And again, we're talking about the second derivative right now because I'm taking the derivative of the derivative graph. So points of inflection occur at negative 5.5 and 1.25. And well, this is where the second derivative is equal to 0. Technically not a point of inflection unless you can show that the sign of the second derivative changes. And it changes because it goes from concave up to concave down. Remember, I'm talking tangent lines right now. The first derivative changes from increasing to decreasing. The tangent lines are changing from positive to negative. So if you talk about the slope of a tangent line, that means you're referring to the derivative of whatever I'm looking at. So if I'm looking at the first derivative and I'm talking about its tangent lines, it means I'm referring to the second derivative. So the second derivative is positive, the second derivative is 0 here, second derivative is negative here. So that's why this is considered a point of inflection. Second derivative is negative, second derivative is 0, second derivative is positive. So there's another point of inflection at 1.25. Okay, let's put all of this together now. So here's that f of x graph again. And this is a summary of all the things that we talked about in the last few slides. So down here in this section, this first derivative, remember this is the derivative graph. So the first derivative right here is negative because the sign of the first derivative is negative. So if the first derivative is negative, it means that the graph is decreasing. And right here, because the slope of the line right here is positive, It means the second derivative is positive. So right here is where it's going to be decreasing and concave up. And then right here is where the first derivative is equal to 0. It changes, the first derivative changes from negative to positive right here. So that means there's going to be a minimum in the graph. And then it changes from decreasing to increasing. It's still concave up because the slope of the tangent line is positive. So it stays concave up all the way to negative 5.5, but there's a minimum here and it changes from decreasing to increasing. So if we kind of draw a sketch of what that might look like, from negative infinity to negative 8, it's concave up and it's decreasing. Looks something like that. And then negative 8, there's a horizontal tangent line, and then it changes to increasing, and there's a minimum right there. So now from negative 8 to negative 5.5, it continues to increase, continues to be concave up, and then at negative 5.5, it changes. There's a point of inflection, and it's continuing to increase. Sorry, I'm going to move this down a little bit. I might run into that graph. Okay, so from negative 5.5, from negative 8 to negative 5.5, it continues to increase. It actually continues to increase from negative 8 to negative 1, where it's going to hit a maximum. But at negative 5.5, it's going to change from concave up to concave down. So there's going to be a point of inflection right here. It's going to look something like that now, where it looks like it's going to be approaching a maximum. It's still going to be it's still going to be increasing, but it's concave down. And then when we get to negative 1, it's going to flatten out because that's where the derivative is equal to 0 again. Okay, now from this point, negative 1, all the way to negative 3, we're going to be decreasing. And we're going to continue to be concave down here because the tangent line here is negative. We stay concave down and decreasing until we get to negative 1.25 here. But then now there's another point of inflection because the slope of the tangent line changes right here. Point of inflection occurs right there. We're going to turn into concave up. And then at x equals 3, the graph changes. It has a horizontal tangent line right there, and now it changes to increasing again. So that graph looks something like that. We can't really place it on the y-axis because we don't have any conditions for it. We don't know where it is. We just know that that's the general shape based on the picture of the first derivative. Okay, next video is another example.